let's continue. Again, as mentioned just now, it's very important for the whenever you want to machine certain workpiece using this particular process, its initial conditions will dictate what's going to happen to the surface. What's going to, in terms of the quality, the surface roughness, so on and so forth. So, so, um, so if that particular workpiece has gone through heat treatment, different grain size, different processing, finishing, for example, rolling, weld joint, cold work, so on and so forth, it will have an effect to the way the material being removed from the surface. Right? So so uh, so it's very important for you to understand that. So if you have a workpiece that being produced using rolling process, then it's different compared to a workpiece that's being produced using casting process, right? So when you etch those two workpiece, then basically the result will be different in terms of surface roughness, in terms of material removal rate, so on and so forth. Right? So that need to be understood, right? Okay. Material removal rate depends upon the chemical and metallurgical uniformity of the workpiece and the uniformity of the solution temperature. So what it says basically, the material removal rate (MRR) or H rate depends on chemical, metallurgical uniformity of the workpiece. So the metallurgical uniformity of the workpiece is very important with regards to the grain size, grain structure, so on and so forth. And also the uniformity of the solution temperature also with regards to temperature. The higher the temperature, the higher the material removal rate going to be. Okay. So casting having a larger grain size shows a rougher surface together with the lowest machining rate. So you have to remember this is etching process. So if you're thinking about etching process, is almost similar to corrosion process, where etching occurs at the grain boundary. So the rate of etch usually is going to be high at the grain boundary compared to the grain surface. Yeah? So because of that, if you have a materials workpiece made of casting process, so casting process will have a larger grain size compared to, let's say, for example, forging process. Yeah? So because of that, basically because of its greater grain size, basically as I mentioned just now, the etching rate, it will be higher at the grain boundary, right? So by the way, I'm going to schedule another session today at 2 p.m. I'm going to send information for you so that you can have we have some time for question and answer, because those are some feedback from you guys from last time, right? So I'm going to schedule another sessions at 2 p.m. today. Would that be okay? Okay, so if we end, we stop at 11. I'm going. Please come back again at 2. We're going to have another session at 2, continuing our discussion for question and answers, so on and so forth. Right. So what I'm saying just now is this. So this is, they say this is the grain, right? So the etching will happen at a faster rate at the grain boundary compared to the grain surface, right? Because the energy level at the grain boundary is much higher compared to as energy at the grain surface. So compare this to a material that has a small grain, right? So if you compare this to this has a larger grain, this has a smaller grain, right? So it actually says that casting has a larger grain size. So because of that, it will etch at the grain boundary much faster compared to at the grain surface. So because of that, it has a rougher surface together with the lowest machining rate. Machining rate will also be lower because the grain boundary ratio to the grain size will be lower compared to this. So if you etch your if you do etching and the etching happen at the grain boundary, so you etch this much faster compared to this material, right? So that's the influence of the grain size on the etching rate and also surface roughness. And if you think about it, compare material that have this grain structure and this grain structure. Usually, material we have will with this grain structure, with a finer grain structure, is harder. Its hardness is higher compared to this, right? So so in general, if you do chemical etching, the harder the material, the higher the etching rate going to be. It's not like conventional machining process. So casting having a largest grain size show the roughest surface together with the lowest machining rate. Rolled metal sheets have the highest machining rate accompanied by the best surface quality. So if you have a rolled metal sheet, you have a highest machining rate accompanied by best surface quality because the grain is being elongated because it's rolling process. So the grain is elongated. So because of that, then basically the then you have a ratio between the grain boundary to the grain surface is higher. Okay? Etching rate were high for hard metals and were low for soft metals, softer ones. So etching rates were high for hard metals. This is in general, and were low for soft metal because of the grain size. So usually this is soft materials, this is hard material. Hard material usually have a smaller grain size. Generally, the high etch rate is accompanied by the low surface roughness and hence narrow machining tolerance. So usually, if you have a high etch rate, etching rate or material removal rate, then basically you're going to have a low surface roughness. Yeah? So then this basically this will narrow the machining tolerance. Okay? Any questions? So basically this is the surface roughness for different materials. So for example, if you look at aluminum alloy, manufactured in three different methods. So you have aluminum alloy, sheet aluminum alloy, forged aluminum alloy, and casting aluminum alloy. So if you look at the surface roughness, the one with the rougher surface will be casting. Second, forged and sheet metal, rolled sheet metal will be the finest in terms of surface roughness. So if you look at titanium, it shows the same trend, but still about the same between the forging and also sheet metal. Right? So this is a surface roughness and etch rate for some alloy after removing 0.25 to 0.4 mm. So this is to give you some indications in terms of the roughness and etch rate for aluminum alloy, molybdenum, steels, columbium, nickel alloy, titanium, tantalum. Right? So this is basically the etch rate is on this axis, surface roughness on this axis. So questions apa ni in terms of the workpiece dalam chemical reagent ni floating ke ada support structure, dia being hang. So if you so it's usually being hang from the top. So kalau tengok selalu is this material is being hang. So I just show you. So this is workpiece materials. There's a hanger there. So workpiece is being hang from the top. So that's why some of the accessories that you need for this particular process is like a hanger. So to hang. So or it can be placed in a basket and then submerged into the water. So you have these are the workpiece material. So these are the workpiece material itself. So this is a bucket. There's a hanger on the top. So you lower it into the chemical bath down there. Right? Okay. So where will we? Okay. Any other questions? Okay. So it says that in okay. So in chemical machining, a metal is dissolved. So this machine phase takes both place at the individual grain. So the etching happen both at the individual grain surface and also at the grain boundaries, right? So fine grain size and homogeneous metallurgical structure are therefore necessary for fine surface uniform of the for equality of the uniform. So the finer the grain size, the better it is for the surface finish. Okay. Um, so surface machine by does not have regular lay pattern. So usually, for example, if you look at the AM process or regular machining process using milling, you have a regular pattern. You have a tool path. You can see a tool path. But CHM, you don't have regular lay pattern. There's no tool path. Based on the grain size, orientation, treatment, and previously induced stress, every material has a basic surface finish that result from time. So basically grain size, orientation, heat treatment, forging, whatever, right? Every material has a basic surface finish that result from the CHM for a certain period of time. So basically, it affect that. So whatever the grain size orientation will affect the chemical machining process. While surface imperfections will not be eliminated by CHM, any prior surface irregularities will be slightly altered and reproduced in the surface. So as I mentioned just now, if you have a dent, if you have a scratch, so on and so forth, on the workpiece material before the CHM process, you still have those after you machine it, but it will be slightly altered, but it will be reproduced on the machine surface. That's what it says. Again, accuracy and the surface machining. Machining rate affect surface roughness and hence the tolerance produced. So in general, slow etching, if you do slow etching, you produce surface finishes similar to original one. So if you do slow etching, you get the surface finish similar to the original one. So slide just now shows the typical sphere roughness and different materials. So that's the graph that we look at just now. So again, the orientations of the areas being etched with respect to the rolling directions or the directions of the grain in the workpiece is also important for good. So basically, the previous processes on the workpiece will have an effect to the surface finish after the CHM process. Okay. So depth of the cut tolerance increase as the machine depth. So basically, the depth of cut tolerance increase when the machining larger depth at a higher machining rate. So if you do at a higher machining rate, as you go deeper, then basically the tolerance become bigger. So it's harder for you to control the accuracy if you go deeper. Aluminium, magnesium alloy can be controlled more closely than steel, nickel. So aluminium, magnesium alloy can be controlled more closely than steel, nickel, and titanium alloy. Right? So we have another 5 minutes to go before 11. I'm going to stop here so that you have some time to prepare for your next class at 11. So again, we're going to, I hope that you can read the slide um, uh, prior to 2 p.m. so that at 2 p.m. then we can have a lot of discussions in the question and answer sessions. Okay. So with that, I think I'm going to end our session now. We're going to meet again at 2 p.m. And continue this session. Would that be okay?
Okay, sir. Okay.
Okay, sir.
Okay, then I'll send the detail.
Okay, Doctor.
I'm going to send the detail on the Zoom at 2 today. So in the chat, right? Okay then. So with that, then basically, I'm going to end the sessions and have fun with your next session. I'll see you at 2 p.m. Right? Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.